Hi everyone. From today on, I'm gonna share all the 30 essays recommended by Ilya. There are plenty of AI and machine learning materials in the internet, but I think these 30 essays are the most valuable ones. It is said that you can understand 90% of the AI technologies if you read them thoroughly. Today is the first essay that I will introduce to you. The essay is titled The Annotated Transformer. It provides a comprehensive overview of the transformer architecture, a pivotal development in the field of deep learning, particularly for natural language processing. This introduction will explore the significance of the transformer model, its architectural components, and its impact on machine learning, culminating in an understanding of why this model has become a cornerstone in various applications. Before we start, if you are new at machine learning, I strongly suggest that you need some books in this area. Here are 3 books I think may be useful for you in your AI learning process. The first one is Essential Math for AI, Next Level Mathematics for Efficient and Successful AI Systems, written by Helen Nelson. You will have a brief and clear overview of machine learning language as well as structure. The second one is Superintelligence, Path, Dangers, Strategies, written by Nick Bellstrom. It's more user-friendly than the first book as it doesn't have much mathematical theory. The last book I strongly recommend is Understanding Deep Learning, written by Simon J.D. Prince. It's a very off-the-rated book that suits all AI learners. The first part is called Significance of the Transformer Model. Introduced in the paper Attention is All You Need by Vaswani in 2007. The transformer model revolutionized how sequences are processed in machine learning. Prior to this innovation, recurrent neural networks and conventional neural networks dominated sequence-to-sequence tasks. However, these models face limitations in handling long-range dependencies due to their sequential nature. The transformer addresses these shortcomings by employing a self-attention mechanism that allows for parallelizing and better representation of input data. Here are 4 advantages of PRS models I summarize. The first one is parallelization. Unlike RNNs, which process sequences one step at a time, the transformer processes all tokens simultaneously. This parallelization significantly reduces training times and enhances efficiency. The second one is called long-range dependencies. The self-attention mechanism enables the model to weigh the importance of different words in a sentence irrespectively of their position. This capability is crucial for understanding context in language texts. The third one is scalability. Transformer can be scaled up effectively, leading to larger models that have demonstrated superior performance on various benchmarks. The last one is flexibility. The architecture is adapted to different tasks beyond NLP, including image processing and reinforcement learning. The second part of the essay introduces architectural components. The transformer architecture consists of an encoder-decoder structure designated to handle input-output pairs effectively. Each component plays a vital role in ensuring that the model captures complex relationships within data. So, what's an encoder-decoder structure? The encoder's role is to process the input sequence and convert into a continuous representation. It compresses multiple identical layers, each containing two main sublayers. The first is called multi-head self-attention. This mechanism allows the model to focus on different parts of the input sequence simultaneously. The second one is called feed-forward neural network. It is a position-wise fully connected network that processes the output from the attention mechanism. The decoder generates the output sequence based on the encoder's representation and previously generated symbols. It includes an additional attention layer that attends the encoder's output, allowing it to incorporate information from both parts, outputs, and input representations. In the following parts, the writer introduced an important concept called self-attention mechanism. Self-attention is a critical innovation that enables the model to compute representation by relating different positions of a single sequence. The process involves three key components. The first one is called queries. It is representation of the current token. The second one is called keys. It is representations of all tokens in the sequence. The third one is called values. It is corresponding values associated with each token. The attention scores are computed using dot products between queries and keys, followed by a softmax operation to obtain weights for combining values. This mechanism allows for dynamic weighting based on the context, enhancing the model's understanding of relationships within sequences. To further enrich representations, transformers employ multi-head attention, which splits queries, keys, and values into multiple heads. Each head learns different aspects of relationships within the data, allowing for more nuanced understanding compared to the single-head attention. Since transformers do not have an inherent sense of order due to their parallel processing nature, possessional encoding is introduced to provide information about token possessions within sequences. This encoding ensures that the model can differentiate between tokens based on their order in sentences. The introduction of the transformer has led to significant advancements across various domains. The first one is natural language processing. Transformers have set new benchmarks in texts such as translation, summarization, and sentiment analysis. Models like BERT and GPT have leveraged this architecture to achieve state-of-the-art results. The second one is computer vision. Transformers are increasingly being applied to image classification and object detection tests, demonstrating versatilities beyond text-based applications. The third one is reinforcement learning. The architecture has found applications in reinforcement learning scenarios where sequential decision-making is crucial. The fourth one is generative models. Transformers enable powerful generative models capable of producing coherent text or images based on learned representations. All in all, the annotated document serves as a valuable resource for understanding how the transformer architecture operates and its implementation details. By breaking down complex concepts into manageable sections with code snippets and explanations. It provides insights into both theoretical foundations and practical applications. As research continues to evolve around transformers, their influence on machine learning will likely expand further, solidifying their role as a fundamental tool for tackling complex problems across various fields. This introduction outlines the significance of the transformer model while highlighting its architectural components and broader implications within machine learning. The detailed exploration provides in the Annotated Transformer will enhance comprehension for those looking to implement or study this transformative technology further.